Amazon rainforest. Amazon rainforest. In a frigid ocean beneath Antarctica, how can a vast undersea waterfall 500 times bigger than Niagara Falls lead to a gigantic feeding frenzy near the equator? Amazon rainforest. In a frigid ocean beneath Antarctica, how can a vast undersea waterfall streaming past the coast of bigger than Niagara Falls lead to a gigantic feeding catastrophe near half of Amazon rainforest in the southern United States? How can a vast undersea waterfall streaming past the coast of bigger than Niagara Falls answers to lead to a gigantic feeding catastrophe thanks to a network of satellites floating high above Antarctica? How can everyone those senses extend far beyond what our eyes can see answers to lead to a gigantic
Really the love of astros of human discovery. We're discovering new things every day.
What are these everyone those senses extend far beyond what our eyes can see answers to lead to a gigantic
Really the love of astros of human discovery. We're discovering new things every day.
What are these everyone those senses extend far beyond what our eyes can see answers to lead to a gigantic
Really the love of astros of human discovery. We're discovering new things every day.
What are these everyone those senses extend far beyond what our eyes can see answers to lead to a gigantic
Really the love of astros of human discovery. We're discovering new things every day.
What are these everyone those senses extend far beyond what our eyes can see answers to lead to a gigantic
Really the love of astros of human discovery. We're discovering new things every day.
What are these everyone those senses extend far beyond what our eyes can
Major funding for NOVA is provided by the following: the David H. Koch and by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you. And Millicent Bell, through the Millicent and Eugene Bell Foundation. Major funding for Earth from Space is provided by the Candida Fund, furthering the values that contribute to a healthy planet.
Since humans first ventured into space, some of the greatest gifts of exploration have been the new views of our home. Who can forget the iconic Earthrise images of the Apollo era? And now from the International Space Station, we have these spectacular vistas. The blue marble is finally revealing its secrets. It's a planet alive with activity and constant change. Its surface transformed by humans, yet still ruled by powerful natural forces that we are only beginning to understand.
It's just spectacular when you view it from space. It's teeming with diversity, with beauty, amazing colors, the blues and the greens and the whites.
You see the world as one huge system, all linked through the atmosphere and the oceans, rolling its way around the sun.
So what is it that shapes Earth's dynamic face? What are the essential ingredients, and how do they combine to generate and sustain all life? How do the natural forces that surround us work together to create an engine powerful enough to nourish and drive life forward in all its diversity? Our best hope for answers may come from above. Orbiting over our heads are 120 satellites, keeping watch from space. Most operate at altitudes ranging from a few hundred miles above the surface of the planet to as high as 25,000 miles. Each one of these Earth-observing satellites reveals a different piece of the puzzle. Each carries an array of exquisitely sensitive detectors designed to reveal what would otherwise be hidden from our view.
The satellites are absolutely amazing because not only can we see the visible things from space, but also we can see things that aren't visible to the human eye. So satellites are enabling us to turn what are invisible processes into visible things we can see and then understand.
To see how our world works, in this program we have taken information provided by satellites, combined it with computer models, and rendered the results in these scientifically accurate graphics. With the invisible now revealed, we can see Earth as an endlessly changing system. These images will show in great detail how sunlight, moisture, land, and atmosphere interact in unexpected ways, with seemingly local events often triggered by forces far away in space and time. And with these new insights, for the first time, scientists can begin to understand the intimate relationship between the planet and all the living things it supports.
It's really the thrill, because it matters so much, of piecing together the story of what the Earth is doing, how it's changing, why it's changing, and how ultimately that affects humans.
The first piece of the puzzle is in understanding the massive influence the Sun, from 93 million miles away, has on our planet.
The world's continuously bathed in a flow of energy from the sun. And that warms the Earth. Everything that you can see that lives and breathes and moves on the Earth is pushed by the sun.
Now, an electronic eye in space can measure the impact of the Sun's energy all around the Earth. One of NASA's newest satellites, named for a meteorologist, Polar Orbiting Suomi, launched in 2011, provides the view. The spacecraft is the size of a small school bus. It orbits 500 miles up, circling the planet 14 times a day. On board, it carries 5 separate sensors that enable it to see things invisible to human eyes. The light that we can see is confined to a narrow band of electromagnetic radiation, just a tiny portion of what the satellite can pick up. Electromagnetic radiation spans a spectrum that goes far beyond the familiar colors of the rainbow.
If you were to consider the full spectrum to be a line that stretched from New York City to Los Angeles, the piece that our eyes could see would be about the size of a dime. There is so much other information out there available to us, and that's in large part what these satellites do.
One of this satellite's key instruments is called CERES, an acronym for Clouds and Earth's Radiant Energy System. It detects in the ultraviolet and infrared that we can't see. This is a Ceres eye view of the planet. Anything that emits heat gives off infrared radiation, so the Ceres data shows the Earth in shades of heat, accurate to a fraction of a degree. It reveals how the planet as a whole reacts to sunlight, both absorbing and reflecting the radiation coming from our local star. At the poles, the sun strikes at an oblique angle, and what little light there is gets reflected back out to space by the ice and clouds. These are the primary reasons why the poles remain cool. At the equator, it's a very different story. Not only does the planet receive more direct sunlight here, the lack of ice means that less of the sun's energy is reflected back into space. And at the equator, the sun's concentrated energy fuels a heat engine that can trigger weather events around the world. Perhaps the best place to see the impact of the sun's heat is an area in the Atlantic just north of the equator and west of Africa, the coastal waters of the Cape Verde Islands. Here, the sea provides a living. The local fishermen keep a careful eye on the weather. They know that storms can bring a good catch. Turbulent weather stirs up nutrients from the deep, attracting great shoals of fish. It's the hottest time of the year, and the sun beats down relentlessly. By late afternoon, the huge inflow of heat energy has led to the buildup of large cloud formations. Sometimes these formations develop into massive storms. It's a process that satellites are revealing in fine detail. Circling above the fishermen is a NASA satellite called Aqua, Latin for water. It orbits the poles. One of its key tasks is to monitor the complex interaction between sunlight and water.
Aqua satellite is one of NASA's flagship satellites. Its primary function is to study the hydrologic cycle on Earth. Vapor in the atmosphere, liquid ocean, the temperature of that ocean, and the ice.
One of Aqua's instruments looks down at the sea around Cape Verde, again in infrared, sensing heat. Highlighted here in yellow, over 1 million square miles of ocean reaches a critical temperature, 80 degrees. At this temperature, the sea is evaporating fast, producing an invisible gas, water vapor.
By looking at the infrared, the Aqua satellite is able to measure the amount of water vapor evaporating from the surface of the ocean.
Aqua shows that this area is producing millions of tons of water vapor every hour. Based on that data, it's possible to create an image of what the vapor might look like if these fishermen could actually see it in the air around them. Water vapor is much lighter than air, and vast columns rise upward directly from the surface of the sea. The water vapor carries with it heat, the energy of the sun.
Well, water vapor is like invisible energy. It's like molecules escaping the ocean, taking heat energy with them, and they're like little mobile solar collectors that are zipping around the atmosphere.
Half a mile up, as the air cools, the water vapor condenses back into liquid water, tiny droplets that form vast clouds. The vapor releases the sun's energy, the heat it received earlier. The result is a storm.
Molecules condense in the atmosphere and become liquid again, and when that happens, that heat is given off into the atmosphere and it warms the atmosphere, and that's the heat that powers storm systems.
In the worst storms, the heat captured by the water vapor is equivalent to up to 200 times the global production of electricity at any given moment. The process of evaporation results in something we don't need special instruments to see. The rising heat drives the clouds up to 10 miles high. As the clouds rise upward, the Earth's rotation causes them to spin. The thunderclouds merge into a vast vortex. This is the birth of a hurricane.